Welcome to aminacademy.com. In astronomy, let us discuss about atmosphere of the giant planets. The atmosphere of the Jovian planets are the parts we can observe or measure directly. Since these planets has no solid surfaces, their atmosphere are more representative of their general composition than is the case with the terrestrial planets. When the sunlight reflects from the atmosphere of the giant planets, the atmospheric gases have their fingerprints in the spectrum of light. Spectroscopic observations of the Jovian planets began in the 19th century. The clouds and atmospheric structure. The clouds of Jupiter are among the most spectacular sight in the solar system, much below the marks of science fiction films. The range in color from white to orange to red to brown, swirling and twisting in a constantly changing kaleidoscope of pattern. Saturn shows similar but much more subdued cloud activity. Different gases freeze at different temperatures. At the temperature and the pressure of the upper atmosphere of Jupiter and Saturn, methane remains a gas, but ammonia can condense and freeze. Clouds lie so much deeper on Saturn, they are more difficult to see, and the overall appearance of the planet is much blander than in Jupiter appearance. Saturn has one anomalous cloud structure that has mystified scientists. The hexagonal wave pattern around the North Pole. The six sides of the hexagon are each longer than the diameter of Earth. Winds are also extremely high on Saturn with speed of up to 1,800 kilometers per hour measured near the equator. Now, let us discuss further detail about the giant planet's atmosphere. The giant planets Jupiter, Saturn, Uranus, and Neptune have deep gaseous atmosphere composed primarily of hydrogen and helium. They also contain smaller amounts of hydrogen compounds like methane, ammonia, and water, which condense to form cloud layers. These planets have distinct cloud layers and atmospheric properties of influenced by their distance from the sun and internal energy. Composition. The atmospheres are dominated by hydrogen and helium with traces of other gases like methane, ammonia, and water. Cloud layers. The presence of hydrogen compounds in the atmosphere leads to the formation of various cloud layers at different altitudes, influenced by the temperature and pressure. For example, ammonia clouds are common on Jupiter and Saturn, forming at around 150 K. Atmospheric properties. The atmospheres of the giant planets are characterized by deep atmospheres. They extend far into space with no solid surfaces, instead having swirling gases above a core. Strong winds, fast rotation rotates and the Coriolis force result in strong zonal east-west winds. Internal heat. Except for Uranus, the giant planets possess significant internal energy which contributes to their atmospheric dynamics, especially their weather. Weather system. The giant planets have distinct weather systems, including large storms like the Great Red Spot on Jupiter and the Great Dark Spot on Neptune. Distinct characteristics. Each planet has unique atmospheric features and cloud formation. For example, Saturn's atmosphere is less visually striking than Jupiter's, and Uranus' atmosphere is generally featureless, possibly due to its lack of an internal heat sources. Upper atmospheric feature. The upper atmospheres of the giant planets reveal interesting phenomena such as the presence of H3 plus ions, which can be used to study atmospheric temperature and densities. Unlike Jupiter and Saturn, Uranus is the almost entirely featureless as seen at wavelength that range from the ultraviolet to the infrared. Calculations indicate that the basic atmospheric structure of Uranus should resemble that of the Jupiter and Saturn, although its upper cloud are composed of methane rather than ammonia. However, the absence of internal heat source suppresses up and down movement and leads to a very stable atmosphere with little visible structure. Neptune differs from the Uranus in the so far we discussed about little about the atmospheric atmosphere of the giant planets. We have done. Please subscribe our YouTube channel.